Job, so let's give him a hand for that. And the only guy that I don't have to tell him how to hold the microphone, Bryan is going to talk about some crypto this evening. So let's give him a hand and learn about stealing server-side secrets through client-side crypto. It's going to be good stuff.
Thanks. That's a good one, by the way. Oh, awesome. Hello. Hello.
Hello, hello. Hey, so first thing, it's not just me that runs the sound here. You know, we've got a whole team of guys who do that stuff now. So applause for them, please, because these guys make this stuff happen. All right, so how you guys doing tonight? Everybody good? Yeah. Awesome. You ready for some hack stuff? Yeah. All right, cool. Okay, so tonight I'm going to talk about, as Jura said, stealing server-side secrets through client-side crypto. Yes, I realize I just read that off the screen. You're going to have to deal with some of that tonight. But let's get started. So, first thing, client-side crypto might sound like a good idea. Yeah, there you go. So the exception is, you know, you hear about all this stuff that's happening in browser plugins and blah, blah, blah. Okay, if you're trying to keep secrets from the server, it might be okay. But in most cases, if you're trying to implement encryption on the client side, you're doing a really bad thing, don't do it. There you go. The reason I'm giving the talk tonight, it may seem like really obvious that you're gonna do this, that you shouldn't do this stuff, but developers keep doing it. So I'm here to say, stop. A little bit about me. Most of you know who I am, but I break apps for a living and then teach people how to fix them, and a little bit of networks too, but that's what we're doing. So the stuff that I'm going to talk about in this presentation are real examples of assessments I did this year. So you're looking at real examples of things that happen in the financial industry that you guys don't ever get to know about because we do the assessments and tell them how to fix them, and we protect your asses. So that's what we're doing. So the first example, a .NET thick client application. When we're doing these assessments, we typically put a man-in-the-middle proxy in between them. In this case, there's a thick client, pretty easy to see everything that's going back and forth. But if you look at the response there, this is a SOAP request, a typical SOAP request, but it includes some data in there that's labeled DNS name, and there's a bunch of gobbledygook. Trained eyes will be able to recognize that as base 64 encoding, and then if you try to decode it, you just see a bunch of garbage. When I see this, what I think is, well, the data is encrypted, it's sent to the client. In order for it to be useful to the client has to decrypt it, right? Otherwise, it's just passing some information along, and why did you bother encrypting it in the first place? So, next step, .NET, so we load up ILSpy and start looking through the code, tearing it apart. Something I found interesting here, look, you see decrypt string triple des. Oh, that's encouraging. Yeah, they just killed the music. Okay, cool. So, you know, if anybody who knows anything about crypto, you might have seen a few things in there. They use triple des, constant IV, no MAC. Yeah, so your translation errors. For us crypto people, there's a glitch in the matrix. Don't really worry about the rest. So that's bad stuff, but who really cares when they give you the key right there? See, in order to decrypt that traffic, the client has to have this information, or it has to have been sent to the client at some point. So the takeaway here is that anytime you're doing client-side crypto, the client, all the data can be extracted from the client, okay? So when the developers put this together, you can see they tried to do some crazy stuff. They put a couple of bytes in there and did some transforms, and they just didn't think we could figure out, you know, this whole programming thing, because that's really complicated. So I could have extracted the cryptocode. You know, we use Python a lot for scripting some of this stuff and breaking stuff in, but that would have taken too long, like half an hour or something. So instead, I decided to do some research, download Mono, figure out how to make it work, and compile the whole thing from source, because I thought that would be faster. No, not really because it'd be faster, because I wanted to learn how to do it and it was cool. So, as you can see there's some commands. These slides will be up later, but if you want to build a library, if you're in a Linux machine or a Mac machine, for instance, you can do that. So yeah, in the middle of a project, cool, did something new. So at that point I said, well, I got a cool working stack, let's load up some library calls and see what happens. Okay, dump the ciphertext in there and literally just made some calls to their library, and we ended up with, what the hell is that? Not yet determined. So yeah, that didn't work so well, but it turns out later on I just needed another request, and it turns out that the encrypted data was actually the backend service that was being requested by the web service. So you've got a web service that's making backend calls further behind it, and now I can control what server those requests are being made to. So in my case, encrypt whatever I want, get those requests to go wherever I want. Yeah, so finding, yeah, great, but not really that exciting. You can change where the requests go, learn some information about it. So the recommendation in this case was to use a hash of the server name, send it over to the client, so there's not actually any crypto going on the client side. It's just a lookup value that can't be spoofed on the backend side, so you just look it up and see what it is. The other part was, or just don't send it to the client. If there's no reason why the client ever needs to change what the web service is calling, you don't ever need to do that, so don't do that. But in the end, no client crypto needed. And in most cases, if you are a developer or you know developers who are talking about building encryption into a client, tell them no. That's basically what it comes down to. All right, so that one, yeah, okay, cool. We did some cool stuff, but didn't really end up with a real good exploit at the end of it. This one, we're looking at a sort of similar situation, but we have a Java thick client. So we're going to go about it in a little bit different way. So again, we're watching the requests. That's part of what we do when you watch for a new application. You just get to know how it works and see what kind of traffic is being sent back and forth when you do things like authentication and sessions and all that kind of stuff. You spend a lot of time just getting to know the process that takes place to make that all happen. So in this case, we saw it's making this request. It says, oh, blah, 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 give me this file. It returns back an encrypted password and a username. But if you look a little bit closer, you see the URL there. Anybody get into something? What does that say?
SQL creds.
Nobody? SQL?
SQL.
Yeah, does anybody know what a SQL server is? Raise your hand if you know what a SQL server is. Okay. What happens if an attacker gets into your SQL server for your app?
Game over.
Yeah, game over. Okay. So, this app, we just talked about this. The client side must contain everything you need to decrypt the data that's being sent to it. And this app talks to a SQL server in the background. And they're sending you an encrypted password. What does that mean? So, yeah, we covered that. Wait. Yeah, we were serious. So the next point is, what did we do with the first app? Well, we're talking about a Java app in this case, so instead of ILSpy, we're going to use JD GUI and decompile the code. Because, by the way, if you're using .NET or Java, your app is completely decompilable. I can see absolutely every call that it makes. And by the way, change the code and recompile it with no problems whatsoever. So after you've done that, you have, in this particular case, hundreds of thousands of files that contain source code, and you start having to just dig through them. So you go through one by one. I use Vim for this and just kind of go through and start looking to see what we have. So I ran across this file. It says import redacted common.security.encryption. Okay, that sounds interesting. We're looking at encrypted data. We want to see if we can decrypt this. So you can see load properties from DB. There's an actual object that's instantiated there, and what you can't see in the lines is the actual call that gets made to decrypt the data. So the other cool thing about this particular project was that all the crypto code was included in one importable jar file. So I could, you look a little closer, yep, there's the key. You need that to decrypt the data. So this is it, 17 lines of code that I wrote and used, and then a POM file to compile the project so that it could make those calls, and there you go. Java.-jar hello, and we have plain text for the password. And then we logged into the SQL Server. Yeah, so we just talked about this. What does that mean? Game over. So especially in a financial services industry, if at any point you're sending data to the client, and I can use that information to get directly into your SQL Server, let's ignore all the SQL injection crap that we found and all the other issues. If I can log directly into your SQL Server, it's over, period. Because you are talking about commonly a multi-tenant environment where you've got multiple banks sharing the same database, and you've got all these clients and all this data, and I'm just walk in there and steal stuff from your bank account because I have access to the SQL Server. So in this case, the recommendation came down to the app was trying to implement a common web application paradigm where you're trusting the fact that a user can't ever get access to the backend system. So you've implemented a application layer credential for the database, single login. So your users log into your application, and they're all segmented, and you've got authorization controls to make sure that they can't cross the boundaries. But in this case, since I was able to control the thick client, and that will always be the case, you can't do that. You can't have a thick client connect directly to a SQL server if you're going to use an application level credential. So either you need to put the SQL server behind a web service call, like a middleware tier is what people call it, or you implement direct authorization or authentication controls so you have an account for every single user who's using your application directly in your SQL server. Again, no client-side crypto needed, and the takeaway is if your developers are saying, oh yeah, we'll just secure that with some cryptography. No, don't do that. That's almost always a bad idea. So the conclusion of this is server-side secrets should never, ever, ever be sent to the client, because I can extract anything I want out of your client, okay? And like I said at the beginning, the exception to that rule is if you're trying to keep secrets from the server. So for instance, if you have a password manager and you want to be able to store that information in the cloud for some reason, but it's your private information, you don't ever want the server to know about that information, then you would implement some type of client-side control. Don't do it in a web browser. There are all kinds of reasons why you shouldn't, but if you need to do that, that is the only exception to that rule. Otherwise, don't do client-side encryption. And that's pretty much it. So, any questions?
Yeah.
So have you heard of SQL ciphers, like an SQLite client-side encryption API thing? And how is that going to be the same thing? They keep that secure by like hiding the password or the encryption key in the client?
I'm not entirely sure I understand your question. So he alluded to SQLite client-side encryption.
Yeah, as for SQLite, it's called SQL Cipher. It's like a library for encrypting SQLite databases. And I was wondering, is this going to fall under the same attack, just the compile?
In general, the rule is if you're trying to protect server-side secrets, if you're trying to keep data secret from the user, you don't ever want to send it to the client, no matter what. If you're trying to keep data secret from the server, you encrypt it on the client side. That's what it comes down to. So if you're using that SQL Server or the SQLite database to preserve something that only the user should ever know, that's maybe okay. I'll caveat the hell out of that because browsers are notoriously bad at protecting information. So if you're implementing it in a web infrastructure for any reason, chances are you're screwed. So does that answer your question?
Yeah, that's good.
Okay. Anybody else? No.
Right there.
Okay. Oh, okay.
So smart cards, I mean, I've seen them, I've used them, but when you use a smart card, does the encryption actually take place on the card? Can you actually create an application or actually using something like that? Does that almost work as a separate device so that you can do, encryption, decryption that way?
It depends on the implementation is the answer. In a lot of cases, it's totally vulnerable because anything that crosses my computer is accessible to me because I can control every bit of that hardware and every bit of the calls. There are very, very few exceptions where all of the processing happens on the card itself and you can't get hardware hooks into it and get access to the data. So your answer is, it depends.
But at least that makes it possible.
Possible, yes, it is possible to do that. I haven't seen an example of it. Anybody else?
That was nice. Well, senior staff is not exempt